The next two parts in question number 2 are parts C and D. Part C says finds the probability that the player gets doubles twice in 4 attempts. So here we found that the probability that they get 0 doubles in 4 attempts. Here it's probability getting 1 in 4 attempts. So I bet you can write the symbolic statement for this verbal sentence. If I were to go here to look at my original tree diagram, to get doubles exactly twice, it could be doubles, doubles, no, no. So that's twice, twice, twice. It looks like there's 1, 2, 3, 4, 5, 6 different branches where we could get doubles twice. Here's my work for showing this. The probability that we get exactly 2 doubles is 4 choose 2, which ends up being 6 branches. And down each of those branches, we're doing doubles twice and not doubles twice. So this is the typical work you would show on your test or quiz. You would show this part first. Then the second part you would show is your calculator, a line here, probability x equals 2 of binomial 4, 1, 6, 2. I'll do that really quickly on a calculator just so you can see that. So here, if I hit clear, I go to second, distribution, go all the way down to option. Oh. I'm having a hard time getting there. Sorry about that. Here it is, binomial PDF. You hit enter, number of trials is 4, probability of success is 1/6, x value is 2, you press paste, you press enter, and there it is. So you always have to label it trials, probability of success, and the number of successes too. The last part that I'd like to show you in this video has to deal with this last one here. Should the player be surprised if he gets doubles more than twice in 4 attempts? This is a very different question. In the beginning we were asked equals 0 doubles, equals 1 doubles, equals 2 doubles, but this one is getting it more than twice. And what does it mean to get doubles more than twice? Well, so far let's look at what we've done here. We found the probability of getting doubles 0 times is 48%. The probability of getting doubles once is 38%. The probability of getting it twice is 11.57%. But it's asking what's the probability of getting it more than 2 times, which is now combining cases. Now we're going to switch from PDF, probability density function of exactly just like one case, to CDF. C stands for cumulative density function. We're going to accumulate many cases. In this case, we want to do the probability of getting more than 2 doubles, which you would show symbolically as probability of the number of doubles being more than 2. So one thing you should know on your calculator when you switch from PDF to CDF is when your calculator accumulates, it's programmed to always begin at 0 and work its way up. So we are concerned with this probability right here. And I've already actually calculated. I did PDF of 3 plus PDF of 4. There is like a quick way to do this where you can say the probability of x being greater than 2 is probability of x equals 3 plus the probability of x equals 4. And you could use PDF twice, add them together, and get your answer as 1.6%. But I want to show you in this video how to use CDF, especially for some problems in your homework and some bigger problems that go more than like 4 trials. So for CDF, we always build from 0 up. So if we're curious about these, what I'm going to do is 100% minus this percent right here, 0 to 2. So the way I'm going to do that is I'm going to do 100% minus binomial PDF of 0, binomial PDF of 1, binomial CDF of 2. Gosh, that's a lot of PDF. So instead, we can combine 0 up to 2 with binomial CDF, doing 4 trials, 1/6, and putting in 2. This number here will always be the highest amount you want to accumulate up to. So we start at 0, accumulating up to 2. So we do 1 minus, if you were to sum all of these from 0 to here, it would be 98 point something percent. And when you're done here, the probability of getting more than 2, it's 1.6%. And that number is less than 5%. I mean, that's really rare. That is what we call statistically significant. And it means that that rarely happens, and if it showed up, if somebody you were playing with started getting doubles more than twice in 4 rolls, you might wonder if they're playing with maybe some fake dice, or just maybe by random chance they're in that 1.6%.